Hey everyone and welcome back. I've had a few people ask me about radius and ball turner attachments for the lathe, and I thought it was a great project idea. I think the most popular style that I've seen are the ones that mount to the cross slide and rotate around a center pin or bearing. I've also seen a few other styles, such as a rotating cutter in a tool post mounted frame, and I could have tried to make one of those, but I didn't have the materials on hand for those ones, so I decided to go with a different style. Now the materials I'm using here are going to be quite basic. It's just some 15, 30 and 40mm diameter steel, some bar stock, and two thrust bearings that were left over from an old project. Now the ball turner will be built into a quick change tool holder, so it can work with the quick change tool post. So the first thing I need to do is cut off a piece of steel and make it into a tool holder. The first thing I'll do is clean up the piece of steel with the fly cutter. With the work cleaned up, I'll put it back in the mill so I can cut the dovetails. And having the coolant running really helps with these relatively heavy cuts. And thankfully the dovetails have a pretty nice fit on the tool post. The next thing I'm going to do is cut a shallow slot down the middle of the tool holder. I'm going to be welding a piece of round steel into the tool holder, and this should help keep everything aligned. And the final thing left to do is drill and tap a thread for the height adjustment nut. And that's the tool holder done for the moment. The next thing I'm going to do is cut off a piece of 30mm steel. The steel will become the main housing for the ball turner. And since I'll be machining it and welding it, I'm going to be making it from some 1020 grade steel. The first thing I'll do is put it in the lathe and clean up the ends. The next thing I want to add is a 15mm hole through the center of the work. Now since drilling a 15mm hole is more than what this mini lathe can do, especially in steel, I started with an 8mm pilot hole and then I switched over to a boring bar. Now in times like this, I could have really gone for a reamer to get a nicer surface finish, but in spite of the poor surface finish that I got from the bore, I seem to have something resembling a close to a free running fit. The next thing I'll do is bore out the front face so I can seat the bearings. And I'm not going to machine it too deep because I want the bearings to sit proud of the housing. With the first side done, I went ahead and did the other side off camera. The next thing I'll machine is the shaft of the ball turner. For this I'll be using some 15mm steel. Of course you could use ground rod, but for this application I didn't think it was necessary. I'll start by turning down the end that will mount on the cutting head. Now because space on a mini lathe is pretty limited, this whole mounting stud is going to be pretty small, and I'm going to be relying on having a good friction fit to hold everything together. With that done, I'll part the piece off. I'll then turn down the back so I can also accept another set of thrust bearings. The next thing I need to do is cut an M12 thread onto the back. As you'll see later, I'll be using a coupler nut to lock everything together and add some preload which will hold the assembly together. Now because M12 threads require a fair amount of material to be removed, about halfway through I finished it off with a thread cutting die. I found that if I do it this way when I'm doing coarse threads, I end up with a much more concentric thread. It seems that the part that I single point cut helps guide it on. And with that done, the ball turner shaft is done for the moment. The next thing I'll be making is the cutting head, and I'm going to be basing the design off the boring head which I made a while back. However, due to the size limitations of the lathe, I'm going to have to modify the design slightly so that it's a lot more compact than the boring head. Plus, I'm going to be making it from some slightly larger diameter steel than I used last year. To machine this, I've swapped over to the independent 4-jaw chuck, since the inside jaws can hold a much larger piece of stock than the scroll chuck. And personally, I try to avoid using the outside jaws if I can. With the pieces now nicely cleaned up, I'll move over to the milling machine so I can start machining them. The first thing I need to make here is another pair of matching dovetails. I'll machine the slot with a carbide end mill before switching over to the high-speed steel dovetail cutter. To be perfectly honest, I wasn't all that impressed with the quality of this carbide cutter, and you will see it in the surface finish of some of the cuts. And seeing as this is my only dovetail cutter that I own, I try to use coolant with it when I can, just so the tool lasts a bit longer before it needs resharpening or until I need to get a new one. With that done, I'll machine the matching dovetail. And that's a pretty good fit, or at least good enough for what I need. Next, I'll machine in the other details to make this a cutting head. First, I'll machine the smaller piece, which will end up being the front half that holds the cutting tool. The first thing that I'll do is I'm going to machine in a flat and then drill and tap a hole. Next, I'll drill a second hole that will intersect with the previous one. Later on, this will have a grub screw that will lock the cutting tool in place. On the other side, I'm going to be machining a small slot using a 2mm end mill. The idea here is that it will make a matching lead screw captive, which will allow me to adjust the cutter and change the size of the radius that I'm cutting. And that should be the front part done for the moment. Next, I'll machine the slightly larger piece, which will form the back of the cutting head. I'll machine in another flat, and then I'll drill 3 holes. The holes will become M5 locking gibs, which will lock the tool together. Next, I'll flip the part on its end, and I'll drill what will become the adjustment threads. And to house the lead screw, I'm going to counterbore about halfway down. Finally, I'll tap the holes. And one thing that I almost forgot to do is machine in the mounting hole. As I mentioned earlier, I want there to be an interference fit to hold this onto the main shaft, so I'll bore it to the correct size. And just for a bit of backup, I decided to add a locking grub screw that will lock the head onto the main shaft. The next part that I need to make is the lead screw, and to do this, I'm going to swap back to the scroll chuck. Now to adjust the lead screw, I opted to cut a slot in the top using a slitting saw. Now it did occur to me to use the rotary broach to broach a hex hole into the head, but I just didn't leave enough material in the head to do that. And with that done, I can now assemble the cutting head. And like I did for the boring head, I make up some brass lugs for the grub screws to push against so they don't damage the dovetails. With the cutting head now done, it was time to weld the tool holder to the main housing. Now when welding this, I decided to leave the ends as they were and just weld down the middle. I just didn't want to risk burning through the end or melting it or distorting it, which would be a fair amount of work to fix. After a little bit of cleanup, I decided to fill up the gap with a bit of filler and give the part a coat of some flat black paint. Now I have used this filler before, but I think it was getting to the end of its shelf life, but I think I made it work. Whilst the paint dried, I gave the cutting head a clean using a Scotch-Brite wheel. The head is made from some 1214 steel, and 1214 steel seems to rust a lot more quicker and readily than a lot of other steels that I've used. In the future, I'll probably end up cold bluing it to help protect it from rust. Now my sanding job wasn't all that great, but it turned out alright. And with that done, I'll do a basic assemble with all the parts that I have on hand at the moment. And my first impressions of the assembly was pretty positive. Everything looks okay and everything seems to move quite nicely. The coupler nut at the back is intended to compress everything together, giving it a sort of preload and taking away any slack in the assembly. The next thing I need to do is drill 2 holes in the coupler nut. One for a locking grub screw and one for the handle to fit into. For the handle, I'll be making it from some hot-rolled low-carbon steel. From memory, this was a bit of reclaimed rebar that I cleaned up on the lathe, and by the looks of it, I didn't do a great job in cleaning it up. The first thing I'll do is cut an M10 thread in one end of the rod. And that looks really nice. To attach it to the coupler nut, I'm just going to weld it in. Now it should be noted that the coupler nut is galvanized, and galvanized steel is not the nicest stuff to weld. It should go without saying, when welding galvanized steel, you should take all the necessary steps because the zinc fumes that are produced aren't all that safe to breathe in. And with that done, the ball turner is starting to look really nice, and for the most part, the main ball turner is now finished. Now before I can start using it, I need to quickly machine up a height adjustment so I can correctly set the height of the tool in the tool post. and that should work just fine. Next, I need to make a cutting insert. Now, because of the way that I've designed the tool, none of the cutters that I have on hand are really designed to work with this tool, so I'm going to have to make a custom cutter. To keep it as simple as possible, I'm going to be using a round button insert. This will save me from having to make a cutout to properly seat, say, a diamond shape insert. The first thing I'll do is I'll take one side down so it fits into the cutting head. Next, I'll flip the part, and then I'll take it down so it's the same diameter as the insert. Finally, I'll drill and tap a hole for the locking screw. And thankfully, the cutter fits into the head quite nicely. With that done, I'll use the coupler to add a final preload, and then I'll lock the coupler in place using the grub screw. The next thing I need to do is set the height of the tool. What I want is the height of the cutter to be roughly on center line with the lathe when it's at the 3 o'clock position. And with that done, the ball turner is now ready to use. The first test cut that I'm going to do is going to be a 30mm ball that I'll make from some aluminium. I'll cut off a piece and then I'll drill and tap a hole in the end. I'll then thread it on to a corresponding arbor. Next, I'll align the cutter on the center line of the lathe and the center of the stock. Finally, I'll lock the carriage and the slides, and then I can start cutting. I started off by taking a 0.5mm depth of cut, and by the looks of it, the tool seemed to handle it really nicely. Once the cut was done, I then undid the grub screws and then advanced the cutter 0.5mm and then locked it back to take the next cut. And even though it was a pretty thin arbor holding the part on, I was actually really impressed with the cut that it was taking. In fact, there was pretty much no chatter at all, which really surprised me. It certainly isn't the fastest method, but I really can't complain as I'm getting a really good surface finish. Once the ball is formed, the last thing I had to do was clean it up using some 240 grit. And with that done, you can probably tell that I've made the final component for the ball turner. I guess it's a bit ironic that the ball turner needed a ball turner to make itself. And that's about it for now. I know this isn't an original method of doing it, but I hope you've enjoyed seeing my take on the method. I hope you enjoyed this one, thank you very much for watching, and I guess see you next time.